Hi, welcome to your lesson on parallel and perpendicular lines. As you know from prior learning, parallel lines look like this. They are two lines that will never intersect. Perpendicular lines look like this. They are lines that are formed when you have two lines that intersect at a 90-degree angle. So parallel and perpendicular. Let's get into it. So first, if lines are parallel, then their slopes are the same. Okay, here we have a purple and green line that are parallel. You can see they will never intersect. But maybe our eyes are tricking us. We can confirm they will never intersect if they have the same slope. This line here, rise 3, run 5. It has a slope of 3 over 5. This line, the same, rise 3, run 5. Slope of 3 over 5. Those equal slopes confirm that these lines will travel in exactly the same direction forever. Therefore, they will never intersect. Parallel lines have the same slope. How about perpendicular lines? Here, the green and the purple are now perpendicular. They meet at a 90-degree angle. Let's take a look at the slopes here. For the purple line, there is a rise of 7, run of 6. That means slope of 7 over 6. For the green line, there is a rise of negative 6. It goes down 6 over 7. Negative 6 over 7. These two slopes have a very specific and important relationship. For perpendicular lines, the slopes are called negative reciprocals of one another. Reciprocal meaning you flip the fraction over. 6 over 7 becomes 7 over 6. And vice versa. And negative means one is negative, one is positive. Okay, so if you ever see that relationship, you know the lines must be perpendicular. One other way to look at that relationship is if you multiply the two slopes, slope 1, slope 2 multiplied, they will be always a result of negative 1. Let's try that with our two slopes here. Negative 6 sevenths times 7 over 6. Yep, the 7's cancel, 6's cancel, so we have a 1, and there's that negative sign. That is very important to remember. So again, parallel lines, equal slopes. Perpendicular lines, slopes are negative reciprocals. Let's apply that in some problems. Here we have the trajectory lines L1 and L2 of two cargo ships. Imagine two cargo ships are traveling, and they travel along line 1 and line 2. We are trying to determine whether the lines are parallel or if the ships will intersect. So if we have an equation for each line, for each ship traveling on a line, will they always stay parallel, or are they headed towards each other a little bit? So it says line 1 passes through these points and line 2 passes through these points. Well, how do we know two lines are parallel? We know they are parallel if the slopes are equal. So how about using the slope formula for line 1 and also for line 2, finding both slopes, and then you can answer the question, are the ships parallel or not? So here are the slopes. For line 1, you should have a slope of 1 over 15. Check your work here. For line 2, the slope should be 2 over 7. Now notice 1 over 15 is not equal to 2 over 7. The two slopes are different. Therefore, the ships are not traveling on lines of intersection. They are traveling, the slopes are not equal, therefore the lines will intersect. Eventually these ships will hit each other if they continue at this path. Okay, let's try another problem. This time we're talking about a roof structure with a perpendicular bracket. So imagine this supports the roof, and here's the perpendicular bracket. So hopefully these are at 90 degrees. That's the design. The roof line passes through these 2 points. So imagine this was passing through these 2 points, and the bracket line passes through these 2 points. Determine if they are really perpendicular. So you're going to do the same process. You're going to use a slope formula. Find the slope of the roof line. Find the slope of the bracket. And then check, are those slopes indicating that they're perpendicular? So remember, you're looking for negative reciprocal slopes. All right, let's check. For the roof line, we have a slope of 2 over 5. For the bracket, the slope should be negative 5 over 2. I hope you got those answers. Now, are those negative reciprocals? Yes. They are fractions that are flipped over versions of each other, reciprocal, and one is negative, one is positive. You can also double check by multiplying the two. Multiply these two, and it does indeed give a result of negative 1. Therefore, they are perpendicular. This symbol here means perpendicular. Okay, Great, try this one here. An architect is planning a quadrilateral structure in the form of a parallelogram. Quadrilateral is a four-sided shape. Parallelogram looks like this. And that means that these two sides are parallel and these two sides are parallel. That's a parallelogram. So here's the following 4 points for the vertices. So they are P, Q, M, and N. We always go in order when we name a shape like this. Okay, P, Q, M, N. So determine if this is a parallelogram. I just gave you a hint about that. If this is truly a parallelogram, then this side will be parallel to its opposite side, and this side will be parallel to its opposite side. So find the slope of each of the 4 sides, and then check if the ones across from each other, or the opposite ones, have the same slope. Alright, so here's the gradients of every one of these segments. And notice what we see here, QM and PN, which is QM here and PN here. Those two are opposite sides, and they have the exact same slope. That means they are parallel. Now check PQ and MM right here. They also have the same slope, -2, -2, so they must be parallel. So we have confirmed this is a parallelogram. Now try question B. Find whether the diagonals are perpendicular. Okay, diagonals in a shape are these. They are the segments connecting opposite corners. So those are 2 diagonals here. Are they perpendicular? In my diagram, they definitely don't look perpendicular. It doesn't look like 90, but my diagram is not drawn to scale appropriately. So how about checking the slope of that diagonal, the slope of this one, and then seeing if those slopes have that perpendicular relationship? Let's check. Here's the slope of one of them, -1, and the slope of the other, 1. Well, these are negative reciprocals. -1 is the same as -1 over 1, and 1 is the same as 1 over 1, and those are negative reciprocals. Therefore, since the slopes of the diagonals are negative reciprocals, the diagonals are perpendicular. And I'll let you know that that happens only in a very specific parallelogram, which is a rhombus, which means basically a parallelogram with equal sides, like a square, but angled like this. All right, let's try this one. We have a tractor pulling a plow, and it is pulling a plow with many attachments like this, so it's making parallel grooves for planting seeds like this. So here's one of the grooves. It is graphed here. Determine the equation of groove L2, so line number 2. So there's going to be another groove, and it's going to be parallel, just like they are here. L2, which is parallel to L1, such that it passes to the origin. So there's another groove that's parallel to this one, passes to the origin. First of all, find the slope of line 1, because the slope, if there's going to be parallel grooves, they'll all have the same slope, right? What's the slope? And I'm drawing a little slope triangle here. Okay, the slope is -4 over 1. It goes down 4 over 1. So that's the slope of line 1. So now, line 2, it says, must pass through the origin, which is 0, 0. So here's line 2. What would be the equation of line 2? Well, we know line 2 has an equation of y equals mx plus c. It's a linear equation. We know the slope must be the same as line 1 right here. And we know the y-intercept, since this passes to the origin, the y-intercept is 0. So we write it like this, -4x plus 0, which is nothing. There's line 2. Now, find a equation of a third groove that is equally distant from L1 or L2. So there's going to be a third groove made by one of these, and it's going to be parallel to line 1 and 2, and it's going to be equally distant to either one. So there's multiple options for line 3 here. Okay, one of the line 3 options can be here. It's equally distanced. Notice that line 1 and 2, when you look at this distance here, it's a distance of 2. So when I drew the next line, I also did a vertical distance of 2 here. So the equation of line 3 here would be, well, that one could be -4x plus 4. Same slope, -4, and then it has a y-intercept of 4 here. Okay, but the other option for line 3 is if it was on this side. Okay, it can be parallel to line 2 over here. So what is the equation of this one? Well, that one is -4x minus 2. This time the y-intercept is -2, but the slope is the same. Main thing you notice that the slope is the same all the way through, and then different y-intercepts. All right, try this one here. A machine is set to make parallel cuts on wooden boards. Okay, parallel. The cuts are made along 2 straight lines, L1 and L2. Line L2 has this equation, Interesting. That equation tells you what about that line? If you just see an equation that says y equals 6, what kind of line is that? Well, I hope you're thinking that is a horizontal line. It's just a flat line going through y equals 6. Okay, so line 2 has that equation. Line 1 also has this slope given to us here. So find x. Okay, think about that. Line 1, if it's a horizontal line, because this shows it's a horizontal line, what will the slope be of line 1? Okay, and since it's a horizontal line, the slope will be 0. Therefore, this little equation for the slope must be equal to 0. So set that equal to 0 and solve. So here's line 2. Oh, sorry, line 2 is given with that equation. Line 1 is parallel to it, so same slope, which means slope of 0. And now let's solve. Line 1 has this slope, but we know the slope must be 0 because these are parallel and there's 0 slope here. Solve this, and you get x equals 3. I hope you're able to come up with that. Last problem. This one is about some planes, and the planes are flying. Hopefully, if planes are flying near to each other, they're flying parallel to each other so that their paths don't cross. So here's the question. A plane flies along straight line L1 with this equation. Determine the equation of line L2, which represents the trajectory of another plane at the same altitude that should not intersect L1. So we know that the second plane passes through point 3, -1. Okay, so we have the equation of this plane, and we have a point that this plane will pass through. So what's the equation of this one? And remember, to write the equation of a line, we need a point, and we definitely need the slope. So do we know the slope of the second plane as well? I hope your answer to that was yes. We know line 1 is this, therefore the slope here is 2, and we know line 2, if it's going to be parallel, must have the same slope. Okay, to be parallel must have the same slope. So here's our equation for line 2. We don't know the y-intercept yet, but we do know this point. So do you remember how to use this point to find this full equation to solve for C? All right, we can substitute that point into our line 2 equation. And if 3, -1 goes in there, we put -1 for y, 3 for x. Solve for C here, it's -7. Now we know the equation of the second plane must be 2x minus 7, because we found the C value, and we know it has the same slope as the original plane. All right, hope that makes sense. Let's keep going. I think there's one more here. Okay, find the equation of the perpendicular bisector of the line whose endpoints are given here. So imagine you know that point and that point. You join them. There's some kind of line here. We need the perpendicular bisector of this line, or this line segment. A perpendicular bisector, so that you know, is another segment that passes through your original one, but it passes it through perpendicularly. That means there will be a 90-degree angle here. Also, it's a bisector, which means it cuts the original segment in half. So this part here is equal to this part here. Okay, so here's our perpendicular bisector. Makes a 90-degree angle, cuts this in half. Now, what do we need to know? Well, we need to know the slope of this one, because then we can figure out the slope of the perpendicular, because we know there's a relationship there. So by knowing this slope, we can find this slope. So how about finding this slope first? And then we can find this slope. And actually, let's create, no, that's fine, let's go. Okay, so, and by the way, I wanted to point out that this is the midpoint here. I called it M because since this is a bisector, M here must be the midpoint of this segment. Okay, so finding the slope of line 1, the red one. Using the slope formula, we get a slope of -1/2. If that has a slope of -1/2, what is the green line slope? Well, it must be 2, because it's the negative reciprocal. Flip that fraction, make it opposite sign. Okay, now we know the slope of this one. So if we know the slope, can we give the equation of it? Well, slope is not enough. We need to know a point also. Do we know a point on the green line? Well, not quite yet, but we do know that the midpoint of the red thing is a point on the green line. So how about finding that midpoint? Do you remember how to find midpoints? Okay, using the midpoint formula. Remember an average of the x values and an average of the y values. And we're taking these values here. So the midpoint is at 3, -2. So now you know a midpoint, you know a point on the green line, and you know the slope of the green line. Knowing a point and a slope is enough to find the equation. Try it. Okay, so line 2 must have this equation, linear equation. We know the slope is 2. Looking for C. Again, substituting a point we know into the equation, 3, -2 goes in, y value, x value, solve for c, -8. Therefore, the equation of the perpendicular bisector. Okay, before continuing, it's important that you just pause and consider this whole problem. This is the kind of problem you should be able to solve on your own without the steps broken down like this for you. So this is what you should be striving for, okay? You're given a little information and you use all the pieces you know, linear equations, perpendicular lines, midpoints, everything together in one problem to get to one final answer here. So pause and just consider everything again. Okay, let's try another one. The last few problems are going to be a little bit longer, a little bit more complex here. So we have a border canal dividing two countries, bridge AB. So the canal runs like this, up and down, okay? And this is a bridge across the canal going from one country to another. It says the canal, the two sides of the canal are perpendicular to the bridge. That makes sense, all 90-degree angles here. Okay, point C, which is 1017, is the midpoint of the bridge. Okay, this is a midpoint. The equation of the line AB is this. So it gives you the equation for the bridge right here. And it wants you to find the equation of the border line, this one here in green, that equally divides the bridge and the canal between the two countries. So we need the equation of this green line here. We know this equation. We know this is the midpoint. So if we know this is the midpoint, we already can maybe determine one point that is on this line here. But how can we begin here? What are some things we know for sure? First of all, we know the slope of the bridge is 1/2. You can see it in the equation here of the bridge, 0.5, which means a slope of 1/2. Okay, if that is the slope of 1/2, it helps us get the slope of this one, the border line that we're looking for. What is that slope? Well, that slope must be -2. That is the negative reciprocal of this one because they are perpendicular. -2. Okay, we have the slope. Now if we can just find a point, we can find the equation of the border. Okay, so can we find a point? And maybe the midpoint is the one we need, right? How do we find that midpoint? Well, it does tell you the location of the midpoint right here. Okay, so now you know that your equation must be this for this border line. There's a slope, there's a c value, we don't know. But we do know a point on that line, which is the midpoint. And I'm plugging the point in right here. 17 for y value and 10 for x value. That allows me to solve the last part of the linear equation here, 37. Therefore, the equation of the borderline must be this. Okay, not so bad. You figured out the slope real quick and you knew a point, and that was enough to solve. Let's try one last concept here. Here's a question before our last question. What is the shortest distance from a point to a line? Well, you could draw this to represent the distance, or you could draw this to represent the distance, and clearly this one is shorter than this one. But is there even a shorter connector between this point and this line? I hope your brain is telling you, if I go straight down like this, that is the shortest connecting line between this point and this line. And notice that that green line is perpendicular. And that is kind of the answer to this question. When you want the shortest distance from a point to a line, the shortest distance is always the perpendicular distance. Okay, that's an important idea, and it's going to be critical in our last problem. Let's see if we can figure this one out. This one's going to be much more challenging than ones we've seen. It's going to bring a lot of skills together. So here's the problem. We have a robot vacuum cleaner located at 410, and you can see this graph here. Here is 410, okay? 410. It currently cleans by moving along a straight line. So here's its path, let's say. And it's going to move from point A to point B. So point B it gives here is 19.5, okay? The robot charging station is located at point E, 6.3, right here, 6.3. So here's the vacuum now. It wants to go there. Okay, again, it's going to start here. It wants to get here, but here's the charging station. Now, the vacuum cleaner will have to return to point E to recharge before it reaches point B. So it doesn't have enough power to go from there to there. It needs to go to the charging station and then back to B. Now, how is it going to go to the charging station? Well, it's designed to travel in the least distance possible, the shortest distance possible. So if it's traveling here, when will it turn off for the charging station? Well, we just talked about the shortest distance from a line to a point being the perpendicular distance. So it will travel here, and when it gets to a point that is exactly perpendicular to this one here, that's when it'll turn off for E, travel there, go back, and then travel here, because that will be the least movement, and that's the goal. So your goal is basically to find the coordinates of point D. That means a point along this green line that will represent the point at which the vacuum cleaner will turn off, go to the charging station, and back. And that point D will make ED perpendicular to AB. I'm going to leave it wide open, give it a try, and then we'll go through the answer together. All right. I hope you were able to come up with something for D. Maybe it's not the right answer, but that's okay. Let's try. So here's the vacuum's journey. It will go like that, then like this. And this is perpendicular, okay? All right. We need, when we're talking about perpendicular, we should start thinking about slopes. What's the slope here? What's the slope here? Because if we can get this slope, we will know this slope because it's perpendicular. So let's start with slope of M1. Slope of this line, what is it? Well, for that line, we know 2 points. We know A and B. Using those 2 points, I'm finding the slope here. So the slope of that line is -1/3. So that's that slope. What does that tell you about this slope right away? Okay, I hope you said this slope must be 3. It's the negative reciprocal. Great, so that's that slope. But now we need more. We need the equation of line AB. Because just knowing the slope of this one is not enough. We also need something more on that one to find this point, right? So let's find the equation of line AB. It is -1/3 x plus c. The slope is here, we don't know c. Let's find c by taking either point A or B and putting it in here. Okay, I took point A, I put it into our equation for line AB. 10 replaced here, 4 here, and that gives me this equation, because when I solve this, I get a c value of 11 1/3. So now we have an equation for the red line AB right here. Okay, we know that equation. And now we want maybe an equation for this line. Because if we can find an equation for this one, and we can find where those two equations, those two linear equations meet, right? Because when we say one equation equals another, we can find where they meet. And that meeting point is our goal in this problem. So how can we find the equation of this one? Do we know more about it? Well, we do. We know point E. We know point E, and now we know the slope. So the slope again for this blue line is this. We know point E. So we're going to plug it in a second. So here's our equation for this line here, the path to the charger. 3 is our slope, c is unknown. Put in the point we know, the charging station, 6, 3. Put it into this equation. Solve for c, -15. And now we have an equation for this line. So we have an equation for red line and blue line. And we know they will meet at the point we need, which is that point here, D. So set this equation equal to this one and solve for x. What do you get? There, I'm setting them equal to each other. Solving this, I would suggest you multiply everything by 3 to get rid of this 3 in the fraction here. That gives us -x plus 34, and then this becomes 9x and -45. This is easier to solve now without the fractions. And x must be 7.9. If you know x, you can find the y value, and that's what we need. We need the full coordinates. So x is 7.9. Put that either in here or in here. Find the y value. Y value is 8.7. So we have just discovered the coordinates of point D, that point where the vacuum must turn off and travel the shortest distance to get to its charging station. Great job. That's an involved problem, but again, you are approaching the point where you should be able to see a problem like this and decipher all the steps on your own without support, putting all the skills you know together to solve it. So how do you feel about this right now? Would you have been able to do this when you tried it on your own? How far did you get? Did you think about slopes? Did you think about equations and their intersections? Anyway, great job following along. We will see you soon. You're doing great.